Hello and welcome to E233. I'm your instructor, Gregory Myers. In this video, we're going to take a look at one of our string or character functions as part of our core.c and core.h. And specifically, we're going to focus in on this video on our char find. Now, our char find function makes a couple of assumptions that we need to address in the beginning. So first of all, it makes the assumption that contents is a char vector or array, not a string. In other words, there is no termination character, an int string termination character. So we're going to see why and how you would handle this differently when we look at its compatriot function, string find. Instead, in this one, we're actually going to use then our contents length. That's the purpose of that second variable right there. So I specifically called it contents length as opposed to n because I wanted us to recognize that that is the length of the contents. The second thing to note is that search is a single char or a single character. And so the idea is I want to simply search through my contents looking for that search character. And the idea is my locations vector or my locations array, whichever way you want to think of it, is going to store the indexes. So it's going to store the locations / indexes of the search character in the contents. And so the idea is you can imagine a long sequence of characters where you can simply look through the entire sequence of characters looking for a match. And every time you found a match, you want to store it in your locations index, locations vector rather. Now, the reason why I'm differentiating the two is because we have to do this a little bit different when we are looking for strings or substrings, because we will be dictated by the end of string character, as well as having to match multiple characters. So if anything, this is a slightly different problem. This char find problem is slightly different. The other reason I separate this out is because this algorithm will actually work with any data type. So in other words, you could provide me with a double contents and a double search. And what I can do then is just simply loop through all of the elements in contents looking for a match and then identify those locations. So if anything, this is a little bit more of a generic algorithm that then you can use later on. So the first thing we want to do is we want to go ahead and create a temporary variable. We're going to call it index. Now, we also want to have a count. And from there, then our index is just simply going to allow us to loop through our contents. So we go and initialize this, or we could use a for loop. Doesn't really matter if you want to use a for loop or a while loop, doesn't really matter. We're just going to go ahead and get in the habit of initializing. So we have our initialization, index equal to 0, count equal to 0. And then what we can do here is for index equal to 0, index less than contents length, index plus plus. What we do is we compare then the individual search value with whatever value is at that location in the contents vector or array. So we say if contents square brackets index, if that is equal to whatever our search character was, then we have found a match. And what does that mean? Well, what that means is that we want to take our locations vector array, and we want to use the count temporary variable to then store the current index. So what we're doing here is we're storing the index of the matched location. And then under the else, we just keep looking. And then in this case, since we're using a for loop, we don't have to worry about incrementing the index. However, every time we find a match, we want to increment the count, which brings us to a problem that we have to handle. We do not know the size of the locations vector. And as you've seen in earlier videos, if we inadvertently increase the size over the declared size of your array or of your vector, you simply start overwriting other locations in memory. And so to avoid that, what we want to do is we want to assume that there will only be a certain number or a maximum number of matches. And this, once again, is where our core.h comes in handy. And so essentially what we're doing is we're saying that we will only find the first 100 matches in this particular case. Now, 100 is completely arbitrary, but the idea is that the principle of it is that you would stop searching once you found the first n number of values. And to be able to facilitate that, we have to have another check inside of this loop. So rather than a for loop, what we should do is reconsider writing this as a combination or a compound if statement using not only the index, but also whether or not the count has been exceeded. So what I'm going to do is, instead of a for loop, I would like to rewrite this. And so I'll say, while my index is less than my contents length, and while my count is less than my n max, which is my constant that I have defined in my core.h, now what we want to do is we want to check to see if the current value matches the search value. So I'm going to go ahead and copy and paste this. We're actually, hopefully now you see that the for loop kind of constrained us. We could have used another if statement with a break, but this is a little bit cleaner. And then the only thing that is required here is that we have an index plus plus. In other words, we need to increment our index. Otherwise, we don't move forward in our contents vector. All right. So once again, we read the value of the contents, essentially character by incrementing our index, as long as the index is less than the contents length. And if we find a match, we simply store the location of that match or the index of that match. We increment the count. And then the very last step is that we return the count, because that way we can tell the calling function how many matching characters we found. So once again, we're going to go back over here to our core driver. We can go ahead and comment out some of our previous examples. You can, once again, you can create another string demo if you would like, or you can continue to use these over and over again. But what I'd like to do is I'd like to call our results, call our character find, but I'd actually like to create one more temporary variable here. I'm going to make this one a little bit larger. I'm going to actually make this, let's say, 20. We're actually going to do this a couple of different ways here. And I'm actually also going to go ahead and use another one of our functions. I'm going to call this one contents. And contents is then going to use the chunk length max We're going to declare then a temporary variable contents, and we're going to do two examples here. So the first one, I'm going to take this sample 05. I'm going to use my string copy, and I'm going to copy into the sample underscore 05. I'm going to essentially just copy a bunch of silliness here. So hello world from everyone. And hopefully I have not exceeded my size. And then what I want to do is I want to use my char find, and I want to use this sample 05 that I just filled using the string copy. And I want to go ahead and specify the number of characters. In this case, contents length is going to be 20. Notice I said earlier that we are going to assume that our input to this is a character vector. It did not say that it couldn't be a string. In this case, it is going to be a string, but we're going to go ahead and use the contents length of 20, which was what we initialized or declared our sample 05 to be. I'm going to then look for a specific character, and to tell you what, I'm going to look for the character E, and then I'm going to specify a locations vector or locations array. So I'm going to come back up here to the top. I'm going to declare then a locations vector. And to keep consistent with what I did just a little while ago, I'm actually going to use nmax to specify the total number of maximum number of locations that I can store. Now, clearly, we are not going to find 100 E's in this string, but we might in the next one. And so what we want to do now is we want to show the location of all of the E's that we find. In order to be able to do so, we simply say for index equals 0, index less than results, index plus plus, and we're going to have a printf, and this printf is going to look a little strange. It's going to look a little sparse. It's going to be a %d and a %d followed by a new line, where the first %d is going to be the index of the locations vector, and then the location square brackets index is going to tell us the location in the sample 05. Okay, so basically the index is the match increment, or the match index rather, and the location square brackets index is going to be in the sample 05. In other words, where does it sit? All right, so let's give this one a shot real quick. We'll see if we've got any mistakes in this version before we then jump into the next version. Once again, I've set this up to use the string demo function in the string demo switch. And you can see here that according to this, the 0th location in the locations vector holds the value of 1, which tells me that the index inside of sample underscore 05, where my first E will be, is going to be 1. So sure enough, if you were to, in your mind, write the index number above each one of these characters, the index equals to 1 would get you a E. And then if you go a little bit further, the 17th index, okay, so index equals to 17. So be patient with me here. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. And you can guess a little bit here. There's going to be 19. And you should have then a fourth value. So in other words, what we want to do now is we want to come back here to the command line, and you'll see that we are only printing out the first value, the 17th value, and the 19th value. Why is that? Well, it turns out I was actually a little careless when I created my string, in that my string is actually too long. So this string right here, this sample 05, basically stopped at the 20th character. So to see what I'm talking about, if I come back up here one more time and I change my sample 05 to something larger, not substantially larger, but just 25, then if I build it one more time and I run it, you still see 0, 17, and 19. And so apparently I was really careless. I actually well overshot my 20. Let's go ahead and jump this up to 30. We know that that shouldn't be 30. We would hope that 30 should be large enough. And so now let's build it one more time. And we also need to go ahead and change the value down here that we hard coded. Let's build it once more. And you'll see that now we're picking up that value at the 24th index. Long story short, be careful about the strings that you pick. Be careful what you use for samples here. In this case, I was a little careless in my length. I underestimated the size of it. Let's do another example though. So in this case, we used the hard-coded sample 05. What if we used the contents of a file? And more specifically, what if we used our sample_wiki.txt? And so the first thing that we want to do is we want to use one of our other functions that we've already written, particularly one of the ones that we have inside of our core driver. Particularly, we can use our file read fscanf, and we can pass to it the excuse me, we can pass to it the file. So file read fscanf. For the file name, we want to specify then the sample_wiki.txt as the input argument. We want to specify the contents variable. Once again, we will end up getting a string back, but that does not prevent us from passing it then to our results or into our char find, and we simply contract then the number of characters that we find that match our search character. And so to make this one a little more interesting, we could, of course, say results equal to char find, and we can pass contents. But then why don't we go ahead and also pass to it the length of the contents. So in this case, what we can do is we can use our own string length function that we have derived, and we can get the length of the string, and we'll start off looking for e's. I would imagine there is quite a few e's in there, and then we will pass our locations vector. And if we build this one right here, we'll see if we have any issues. And as we would expect, there are quite a few E's. And so we're seeing a little bit of noise left over. Why don't we take just a second to come back to our file read fscanf. Let's go ahead and turn off the printfs in these earlier functions. We don't actually need them in this case. They're just useful to have to be able to verify that we're actually getting the contents of the file. In this case, they're just creating a little bit too much noise, but you'll see that we actually found 88 E's within the first 1,000 characters. And just for curiosity's sake, I want to see maybe we can find some more unique characters here. How about instead of the E, how about if we see if we can't find, for instance, the exclamation point? I don't actually know if there are any exclamation points in our file. All right, let's see. Turns out there are absolutely none. What about a period? All right, so you can see the location then of all of the periods within our sample wiki.txt. And I am not going to bore you by counting out the number of characters in this file. All right, so hopefully you found this video useful. Once again, we are looking at a char find function that allows for us to search for a single character within either a character vector or a string. It makes the assumption that we are looking for a character within a character vector. Therefore, it uses the contents length. As always, hopefully you found this video useful. If you have any questions or suggestions, don't hesitate to email me. And thank you for watching.